In this section, we will be discussing soluble proteins involved in the innate immune system. So the soluble proteins come in lots of different flavors. We have acute phase proteins, interferons, complement proteins, which we'll include here just as an overview but cover in a different section, and then proteins involved in fever, or pyrogens. So specific to acute phase proteins are C-reactive proteins, as well as ferritin, lactoferrin, transferrin, and haptoglobin. C-reactive protein specifically is made in the liver in response to IL-6. It's thought to be involved in complement and phagocyte activation, and is commonly used by doctors to assess inflammation as part of workups for different infections, fevers, possible autoimmune type settings, inflammation, that kind of thing. CRP is often followed to assess inflammatory state. Ferritin, lactoferrin, and transferrin are all iron-binding proteins with various antimicrobial, antibacterial, antiviral types of functions. Haptoglobin binds to free hemoglobin. All of these are considered acute phase proteins. All of them are increased in acute inflammation with the exception of transferrin, which is actually decreased. However, they do all have antimicrobial functions and are thus considered acute phase proteins. Interferons are a class of cytokines that are typically produced in response to viral infections. They come in two flavors, type 1 and type 2. Type 1 interferons promote a general antiviral state. Interferon alpha is made by leukocytes. Interferon beta is made by fibroblasts. Both of these are induced by PAMPs, by double-stranded RNA or certain single-stranded RNAs, and promote, again, this general antiviral state. Type 2 interferons are made by different cells within the immune system, and they're involved in cytotoxic mechanisms. They're involved in enhancing a cytolytic response. Interferon gamma specifically is a type 2 interferon that is made by NK cells, CD4-Th1 type cells, and CD8 T cells. And again, it's involved in promoting an antiviral type of response, a cytotoxic type of response. So getting a little more specific with the type 1 interferons, this is really a way in which the cells in your body work together in order to affect the common good. So what happens is a cell will become infected with a virus, and as part of this infection, once it knows it's infected, it will increase its production of type 1 interferons. And practically any cell can do this. Once it's infected, it will increase and secrete these type 1 interferons, which will then go out into the environment and will be picked up by the neighboring cells. And if you look at the functions here, it's really cool what this does. So it gets into the neighboring cells, and it causes inhibition of cellular proliferation within those cells. It also increases ribonucleases and proteases in the cytoplasm. Why would it want to do that? Again, it's worried about a viral infection. So where do viruses live? In the cytoplasm. So if it increases its ribonucleases and proteases within the cytoplasm, it will actually prevent the viruses from being replicated within the cell. These type 1 interferons also decrease protein synthesis within the neighboring cells. Why would that be important? Again, viruses. These are pathogens. They're parasites. They get in and they use your own machinery. So these interferons actually turn that machinery off, again, so the viruses can't replicate. Type 1 interferons cause an increase in MHC class I expression on virally infected cells to promote their recognition by CD8 cytotoxic T cells. This is important because that's what CD8s are looking for. So these type 1 interferons actually cause an upregulation of MHC class I, allow more of a chance that there's a CD8 T cell that will come along and see its specific antigen within the context of MHC class I and be able to kill off that cell. It also increases the cytotoxic actions of NK cells, which we mentioned in an earlier lecture, that are involved in recognizing altered self cells, such as virally infected self cells. So these type 1 interferons are really good at evoking this general antiviral state. It's kind of like one cell gets infection, it wants to warn its neighbors so that its neighbors can be ready, and it does so through these type 1 interferons. Now type 2 interferons, again, this refers mostly to interferon gamma. If you see type 2 interferons on the boards, you should think interferon gamma. What does this do? Activates phagocytic and antimicrobial capabilities of macrophages. So it'll go talk to the macrophages and enhance their ability to first of all, effect phagocytosis and also secrete cytokines as well. Type 2 interferons, such as interferon gamma, also increase expression of MHC class 1 and MHC class 2 on antigen-presenting cells. That's good for T cell recognition, right, and evoking this T cell type of response. It increases the cytotoxic actions of NK cells, similar to type 1 interferons. It also promotes the CD4-TH1 response. The TH1 response we'll get into later promotes a cell-mediated type of inflammatory state. Again, going back to the idea that if we do this, we can enhance phagocytic killing activities. So enhance this cytotoxic ability, this ability to kill off things. Now, fever proteins. Well, what is fever? Normally, body temperature is regulated by the hypothalamus, right? Now, this can be influenced by the immune system, and there are different people that say that this is mediated by IL-1 or mediated by IL-6. In any case, these are cytokines that are first produced by leukocytes, white blood cells, or infected cells, and then through an endocrine type of action, they release these cytokines, these pro-inflammatory or pyrogenic cytokines into the environment that will then go into the brain, affect this increase in body temperature, and then the brain itself can actually start to produce these pyrogenic cytokines, IL-1, IL-6, TNF-alpha is also included in this list, and we get an autocrine or a paracrine stimulation, so the fever self-stimulates itself within the brain through these cytokines. So let's talk a little bit more about these pyrogens. We start with the cell walls of bacteria, especially gram-negative bacteria that contain endotoxin or lipopolysaccharide. This LPS can stimulate monocyte and macrophage production of cytokines. We've kind of talked about that with the TLRs. IL-1, IL-2, TNF-alpha, IL-6. These cytokines will then go through and effect activation of different types of cells. Specifically with the IL-1 and the TNF, we get increased neutrophil activity. Now, the IL-2 will then increase interferon production, promoting a TH1 type response again. It can also increase interferon production by other cells, the interferon type 1s, which would promote this antiviral state. We get decreased plasma iron, which also is a result of these pyrogenic cytokines, IL-1, IL-6, TNF-alpha. So, overall, some cytokine pearls, things that you really, really should know going into the boards. If you really don't like immunology and really don't want to study it, these are things that you have to know about cytokines. IL-1, IL-6, TNF-alpha, pyrogenic. IL-6, also an acute phase reactant. Interferon alpha and beta, think of those general antiviral activity, okay? And IL-5, remember, activating eosinophils. If you see IL-5, you've got to be thinking about antiparasite and eosinophils. So, question. As an intern, you get paged at 2 a.m. because an immunocompromised patient spikes a temperature of 38.8 degrees Celsius. You ordered 2 sets of blood cultures, a urine culture, and a chest x-ray. Then you ask the nurse to give the patient acetaminophen. What substance in the serum are you hoping to decrease? And this is a K-type question, meaning there's more than one answer. The answers are A, IL-1, and D, TNF. Again, febrile patient, you don't know why they have a fever, so you start to do a workup there with your blood cultures. You give them acetaminophen or Tylenol. What's the function of that? Well, that's to reduce the fever. That's to bring down the fever. So you're looking to affect pyrogens, IL-1, TNF-alpha, and remember the other pyrogen, IL-6. That concludes our discussion on soluble proteins. In the next section, we will be discussing acute versus chronic inflammation.